yes. All right. So Victor is coming today.
Sorry, I missed that.
Sorry, I was asking, is Victor coming today?
You should be.
Yes. Okay. All right. Okay.
Sending him a message.
So just to confirm, I think we have a discussion with GJ, right?
Tomorrow, yes. Yeah.
Tomorrow, right? Okay. Tomorrow,
Yeah.
same time, right? Okay.
Yeah. Yeah. I sent a meeting invite to everyone. He seems quite excited to talk about the possibilities, so that's good.
All right. So.
Oh, yes, Victory.
Yeah. All right. Good, Victory. All right. So hi, Victory. Can you hear us?
Hi, Shunyun. Can you hear me? Hello?
Yes, we can hear
you. All right. Okay.
Good morning, sir. Sorry, I'm late. Just I sort of lost track of time.
Okay. All
How
right.
are you?
Good. So yeah, we can, I think, start. All right.
Can we
Let's
start?
just jump right into it. So maybe some updates on your side first. Thanks.
Yes. Okay. I'm just gonna share my screen now. Hold on. Where are you? Share. So I'm just looking for my Word. There. Okay. Sure. Can you see my screen?
Yep.
Oh, sorry, sir. Herman.
Yes.
I was supposed to come in today. I know that. I have meetings from like 8 o'clock till 2 o'clock.
That's fine. That's fine, Victory. So my wife,
It's a
is an OT. No, don't worry. So my wife is an OT, and she was in contact with a patient that was tested positive for the virus. So I have to stay at home anyway today.
Yeah, you have to stay at home.
The results are out. Yeah, so I won't be coming in today as well. But anyway, let's jump into this.
Oh, okay.
What may you say? Your
sorry.
wife?
No, she's an occupational therapist, and one of her patients tested positive. So
I see. Okay.
yeah, so she did her test yesterday, but it will take about a day or two. But until then, basically we self-isolate until we get the results. I don't think it's going to be positive, but better safe than sorry. So.
Okay.
Cool, but okay. So.
But as long as everyone is fine at home.
Yeah, no, everyone is fine. Oh.
Okay.
I mean, someone asked me how is it, I said, well, it's basically just exactly the same as the lockdown. So we stay at home and work from home. So,
anyway. That's awesome news then. That's fine. Yeah. All right. So I've tried to sort of expand on basically each section a bit into more detail. I hope I'm gonna. So the last time we spoke about how they should like the solution, the problem, how it's unique and why it's new. So I didn't necessarily title the sections as what the problem is or what the solution is, but the problems are in the subsections. And I'm gonna like show you as it goes, as I sort of go down. But I don't know. Can you see the screen, or is it too small? I don't know if I should.
Yes. You can enlarge it. It's maybe just one page at a time. Yes.
Okay. All right.
But it's visible. It's visible.
Visual. Okay. Okay. So first, the idea is to start with the background, to discuss the current state of network technology, just to bring a very basic picture for anyone. I mean, if a 10-year-old was to read this part, they should be able to understand what's going on here. So the idea is, okay, the current number of phones are growing at maybe at a certain rate. The number of because of the number of devices being developed, maybe billions of devices being developed every year, which means more resources are required to manage these resources. And basically, at that rate, if that continues, there basically will be, it becomes problematic in the future in terms of costs and and managing it on a robust network, right? So And then we would sort of talk about the routing type, the current routing types, how they work in general. This is, I think I got this from Professor Herman. The packet switch types, the static and dynamic routing, how they work in general, the usage, the advantages, their limitations, how data is sort of managed, how it's sort of how they communicate with each other, how what's the word now? How are the packets how are they managed actually? When packet is lost, what happens? And in terms of scalability, what happens as well when that happens? And then how does scalability occur in each system? And what are the challenges of the routing protocols? Like, okay, bottlenecks when it's high costs, for example, as the numbers increase, how the data is managed for how spatial data generally is managed, and maintenance costs, right? Okay, so this goes into a bit more general detail for the current state of technology. So it's like, okay, so it sort of links back to the current state of the general format of phone and storage users, that okay, if this continues, we would need maybe thousands of more servers, and phones would be, for example, in terms of the IP routing. I mean, I think the reason why we have IPv6 now, it's because at the current rate, I think we would run out of IPs for IPv4. So basically, we're gonna run into problems in the future because of the current rate, or should I say the current systems that we have in place. So then go then into like a brief overview to sort of just talk about what we're going to, how spatial routing can potentially solve, or should I say spatial P2P routing can potentially solve some of these challenges. Just very brief. And then in the second section is going to go into related work. Now there we'll go into a bit more detail as to the types of routing, the static based routing, for example, when we have the GIS, where it's basically maps. So it's almost like you're pinpointing locations on the map. It's not necessarily moving around. It's just somewhere. How they solve those problems, how the different approaches, the shortest distance method and all that. And then we go into dynamic routing in logistics based industries, or industries like Uber, where people are constantly on the move, or stuff like DHL, where they have to sort of manage, as they have parcels, they can sort of manage their distribution techniques. Like how do they approach it? How do they solve long distances and short distances? Their limitations, like what were the limitations to the different approaches they applied? I remember reading about how some of them even combine protocols. They combine shortest distance with what's the other one now? I can't remember the name now. But yeah, the how they combined all of this, and how they measured performance, right? In terms of, okay, did it take a shorter time? Was it time they used? Was it fuel? Was it distance? How did they measure performance in general, right? And then we go into spatial routing, what it is, what is spatial data, how is spatial data different from normal data, if that makes sense. And then it would go into spatial P2P, so this decentralized spatial networks. That's where the VON example, or should I say application from Shunyun, I think you have spoken extensively on this. I think you're probably I don't know. I'm guessing you're the only expert in this field, because I don't think I remember.
So, well, no, I wouldn't say it's the only. There are many other researchers. Although I was lucky to be the first. Okay.
Exactly. So you have written extensively on this. So a lot of the writing here would link to a lot of your papers, and I hope you don't mind. But I will reference you. Obviously, it's not like it's plagiarism or anything.
But well, you should reference related work extensively. actually.
Yes,
That's
it will
the
be
rule of thumb.
extensive.
Yeah.
Yes. And also, yes, the approach you took, what was the thinking behind it? I think this is where your master's thesis comes in, because I remember it was quite detailed in describing the thinking behind the application. All right, what was the thinking behind it, and how it can be applied. So I think you applied it in Minecraft, how it worked. So how did the nodes communicate, right? How virtual obstacles were detected. So again, this sort of falls under the problem. It's more general now, but it's more specific. Sorry, in terms of spatial routing, what were the communication methods? How did the nodes communicate with each other? How did they wait to receive information? For example, how were virtual obstacles detected? I think that will be key. And how did you measure performance? I do remember, I think you measured a bit of latency and bandwidth. I have to look at that again. But and also in terms of
There were actually correctness matrix like consistency, and then
That's right,
performance
yeah.
matrix like bandwidth and latency.
Yeah. So in other words, that had to do with, because the nodes all have a spatial location as well, but then the question was, how accurately does the other nodes know that information? And that was to do with the correctness and the consistency. The consistency also had to do with if nodes are aware of their neighbor. So if they have a neighbor, that they should be aware of, do they know about them? So that was the consistency as well.
Okay. Well, and actually it was accurate from what I understand. I do remember you didn't like look into security and that kind of stuff, but like it worked.
It was accurate. Yeah, I think security is definitely something that, for something like this, especially if you have something, I don't think it's something that you need to look at, Victory, but I do think it's something that's going to be a key component here, because if you have other people's packets being transmitted by all people that are part of the network, then I think security does become something that you should keep, that should be included in the routing algorithm from the start.
Okay. Oh, that's fine.
Okay, but I would like to add, don't put the emphasis too much on security for now, because right now, I think,
precisely.
Your main point is more about, creating spatial routing, maybe as a generalized or generalizable model or service.
Right? All right. Okay, that's fine. And then basically scalability. What was your thinking, or should I say, what was your theory in terms of how you were able to scale up without breaking the system, right? So our approach, so this is where sort of our solution sort of comes in, where we say we are trying to apply spatial routing in Smart Factory, and we are going to use the vast, scalable, this sort of go together for Renoir vast library, right? And so the question is, how do we apply this solution that has been created in a different field, into a smart factory, right? Also, has it ever been done? I don't think it has ever been done, but I would have to say that with boldness by reading a lot more papers, but I don't think it has ever been done. There might be something maybe with decentralized systems, but as to whether it was VON, I don't think I've seen anything like that. Also, basically, the new application means it is unique to the IoT field. In IoTs, I don't think I've seen anything like that. In IoTs, I have seen papers where they talk about how they manage, server computations. They did not try to reduce the cost per se. They sort of did maybe they sort of managed the data being record. Sorry, a lot of the solutions I found that they solved the computations first in the systems themselves, in the devices, before they communicated to servers. And again, that works, but there are some things that sometimes require server, like server computations, and in an IoT context, it gets expensive, especially with stuff like Google Sheets, for example. That has to be constantly synchronized with the server, and that's it doesn't necessarily stay on your computer. It goes immediately. You type in something in like Google Sheets, it automatically, and the moment you have billions of people doing the same thing at once, then it gets expensive. While it could work, why it could work, well, it's cost effective. The decentralized system means evenly distributed resources across multiple devices. um, and also scalable system means thousands of devices could be added without the potential, the additional cost by existence. So we can sort of add thousands of users or tools or devices in the factory without being worried about, or what about more server costs, or and in a place like a Timber Labs, for example, where there's a lot of data acquisition, this is something that I believe would be very interesting for them. It's also potentially a solution for multiple fields across science and technology. So if it works in a smart factory context, then I do believe it's something that can sort of be like a rollout for more physical devices, or should I say for more front-end devices, for consumer-based devices. It's like a good way to start. So if it works there, then someone can decide to develop his own product that uses spatial P2P. You can decide to develop his own smart car without worried about extreme server costs, right? So potential challenges, I think so far it's communication when physical obstacles, are involved. How do we communicate with physical obstacles, with stuff like radioactive or thick walls or radioactive rooms? How would that work in a virtual environment? I think everything, there's like the assumption that it's just close to you, but in a case where there's physical obstacles, how would we counteract that? Would we have to get sensors that go through walls, or does that even matter? Basically questions like that would basically be forced to ask questions like that when the system has been, or should I say first system has been developed. And then the management of spatial data from devices constantly on the, which is I see it's like almost 20 past, sorry, but yeah, I think that's more or less it. And then our P2P approach, basically in terms of should I say technical approach now, and how do we measure the performance of our approach. And then we'll talk about the preliminary simulation and results. This is where I basically just talk about the JavaScript Vast library, the one I'm sort of working on, the one that I showed you in the past, and then a graphic illustration of how it works, the virtual version. And then again, our potential challenges will be discussed here, and future work, like what we plan to do in the future to sort of basically it's summarizing all of this and saying, okay, we want to build A, B, C, D, right? Build
nice.
the actual system. Yes.
All right. So Herman, any feedbacks?
I mean, I think this is quite comprehensive. I think that's good.
Okay.
Yeah, I like. Yeah, I mean, the trick now is to go and flesh this out.
Okay.
The one thing I think is it would be nice if we, for the preliminary simulation and results, if we have if we have kind of a first stab at something that does spatial routing. So, but I think for now, in other words, what I say is that I think it. I mean, we could look at the work that Miguel Smith did, but I think the problem there was it doesn't actually do multi-hop routing. So I think it would be nice to have some initial implementation with Vast, where we do some kind of a spatial routing, even if it's just a initial system that does something stupid. But basically does multi-hop routing from a source to a destination, and we can measure some of these metrics that you have in terms of consistency and things like that. But what the structure that you have every year, I think is good. I think you should yeah, that's probably more than 6. This is good. Now
Okay.
you must go right about all these things.
All of them. Yes.
Yeah.
Yes. Yes. Okay.
All right, good. Thanks, Simon. So my feedback there are a couple. One is regarding related work and concepts. I think that should be somewhat separated. Okay. In a sense
Okay.
that I can see that you have described some of the concepts of the work, sort of like your proposal and why you're doing this, right? In the related work part, but I think that should be part of the solution or part of the introduction. You see?
Okay.
Because when you're talking about your ideas, that usually belongs to either, the proposal part or the introduction. But
Okay.
when you're talking related work, it should mostly about an objective description of what others have done and how you compare to them.
Okay.
All right?
Okay.
You see?
Good.
Try to make it clear. This is important too in terms of the presentation and writing. Like, what are
Okay.
the ideas that you propose, or the authors have proposed that's new in this paper, versus
Okay.
what are some concepts that other people have already published, have already done. Because this is, as I understand, in academia, because scholars tend to live by credits. So, like who has this credit? Who proposed this idea first? Who was the first to, mention certain thing? That is usually that's the currency in this field, in this world. Okay.
Okay.
So make sure you are very clear about the concepts, the credits, in terms of like whether this is your original concept or is this something someone else's, right? Okay, and are you adding something to it? Okay, you should also make that
Okay.
clear. Like how are you different, right? That's one feedback. The other part, okay. I think for the one of the challenge, I think the other thing you could mention is proximity. Okay, you talk about blocks, physical blocks, and communication
Yes.
problems, right?
Yeah.
But proximity issue is also a challenge, right? We talk
Okay.
about I think last time when you're out of, or maybe I don't know if you group that under the communication, okay, the communication devices, but I think that's dynamic. Sorry, you talk about dynamic and also physical obstacle, right? So physical
Yeah.
obstacle, dynamic spatial data, but I think another one is proximity. Okay, because
Proximity.
you could be out of range. You could have out of range communication, and you have to make sure somehow the algorithm or whatever you're using can accommodate,
Okay.
an out of range communication issue.
Okay.
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 There's a term called delay tolerant network. You can Google this and maybe do a bit of search. It's called delay tolerant network. I think that's
Yeah.
the academic term to describe networks that may be able to accommodate, such
Okay.
scenarios. Usually they are used for things like military applications, or some real difficult physical environments. Yeah.
Okay.
But again, I mean, in the IoT field, I guess when you're doing things outdoors, you could be facing those kind of environments as well.
Oh, okay.
Okay.
So
All right.
like a harsh kind of environment.
Right. So yeah, so that's the potential challenge part. Okay. You might want to make a note on the
Yeah. I'm
proximity.
writing them down. Yeah.
Okay. All right.
Potential.
So all right. So I think for the next step, so I can see this is already the skeleton, pretty good for a research paper that could be submitted to something like MMBE. Now I think the other important part is to have the actual, I guess the actual concept and design right.
Okay.
Okay. Yeah. So this is something you already mentioned about the questions and So I guess usually people will, you can think of this way. Every paper has a few, and sometimes even just one like really good idea.
Okay.
Like if you can really struck this idea into people's mind as to why are you unique and different, like sort of like what is your special sauce,
Okay.
and it's clear to people, then it will be, I think, a good paper that people will appreciate.
Okay.
Okay. As readers or as scholars, they tend to read tons of papers. Okay. So
Yeah.
I guess my question or my challenge to you is you need to like sharpen up, like just
Okay.
maybe just one concept that
Okay.
is particularly important, novel, and special, unique to your work.
Okay.
Okay, and what is it?
Okay. Sorry, let me just write
Okay, it could be the way you describe the problem, but oftentimes it's how you deal with it in terms of your
that.
solution.
Okay.
Okay, so I think the next stage is to really help you to get that piece, like right.
Okay.
Okay, and
So that-
also this also serves, like as Herman or I, when we talk to people about your work, we need something
Okay.
like really, really simple and
Okay.
obvious, so that these other professor friends can like easily grasp.
Oh, yeah. Yeah, I see
You can
what
think
you
of it
mean.
this way, like how are we going to promote your work, right? What can we
Okay.
say, right?
Okay. The marketing terms.
You see? So I
Okay.
guess what I'm trying to say is a good research work is composed of many parts. Obviously, you need to have solid work, that's
Okay.
whether it's in the code, the simulation, the verification. But a lot of time then at a potentially higher level, it's whether you really have a good concept that you can explain clearly and
Okay.
that's easily understood by people, easily understandable. Okay, and if you can do that, you actually nail down maybe 90%, 80% of the work. You see?
Easy to explain.
Do you see what I'm saying?
I see what you mean. I see what you mean.
Okay. I mean, it's the same in other fields as well. Like in the startups or in the marketing fields. It's if you can present just one thing, one concept, like really that stands out, that people take note of, are impressed by,
Okay.
right? Then
Okay.
what is your one thing? Okay, so
Okay.
try to think of this question hard. It's deceptively simple, but it's not easy to answer actually. Like, what is your one contribution or what is your one concept?
Okay.
Okay, you might list a
Mm.
few. However, if you can make one really, really stand out, that usually is much better than like 5
Okay.
concepts or 5 ideas. That's kind of mixed here and there in the paper.
Okay.
All right.
All right.
Okay. So
Yeah,
I
but
guess
this-
any feedbacks from Herman?
Yeah, so I mean that is also the thing for your PhD. That is the thing you need to get right for your PhD. So I think it is important.
Okay.
I agree with Shunyun. It is important to have that clear in your mind.
Yeah. In some way, it's kind of like the whole process is try to really, really start sharpen out that single one contribution.
Yeah.
That I'm pretty sure you got that. In this, if it's a new field, and if you have some good ideas, if you're tackling an important problem, then definitely there's some important concepts there. Yeah, but you need to sharpen up. But what is your one concept?
Okay.
That would unify all the other works that you do.
Okay. One.
All right.
All right. I don't know if you've Shoni, I don't know if you've considered the commercial student coaching program.
Oh, okay. Are you suggesting me to open up?
You really should. I don't know. Maybe I'm just saying stuff, but anyways. But thank you very much.
Okay.
I do
Yeah. I hope that's helpful. All right.
it is very
Okay.
helpful. Yes.
All right.
Thank you
Okay.
very
So that's SynCon Thursday. Okay. Again.
All right.
And I like and try to again write down as many concepts regarding your one thing, but present your one thing first. Okay.
Okay.
And then lay out all the details. So this potentially, I think it's in the section, in the third section. Okay. Of your work,
Okay.
of your
In the
paper.
third section.
So
Yeah.
that's the part I like to focus next. Okay.
Okay. Third section.
Okay.
All right.
All right. So
do that.
any other comments from Herman?
No, I'm
Uh,
good.
Can
Okay,
I ask
okay.
quickly,
Yep.
Shunyi, I know you record some of these sessions. I don't know if they are publicly available, all of them.
Yeah. Well, it's. I think it's shared to you. Or I'll share it again. It's in the Bassverse channel, I think.
Oh, okay. I
Just
don't.
go dig it and maybe tag it.
Okay.
Right,
I'll look for it now.
yeah. Okay.
YouTube. All right.
Yeah,
Thank you
I'll
very much.
share the list later. Yeah.
All right.
Okay, but I think Herman, I think Herman has seen it, right? It's actually a list.
I think so, yeah.
Okay, okay,
Well, I think-
all right,
I'll have
okay.
to check again.
It's
I
in
do
Slack.
have of the mastermind.
Okay.
Yeah,
All right.
that I got, yeah.
Yeah. Okay. All right. Okay. I'll share it
Okay.
again. Okay. All right. Okay.
All right. Thank
So talk on Thursday then.
All
Okay.
right.
Yes.
All right.
Okay,
Okay. Yeah.
cheers,
Bye bye.
guys.
Yeah. Take care. Yeah. Take care.
Bye.
Yeah. Bye bye. Bye.